Right, this is Calculus Section 5.2, Part 2. So last lesson we talked about all of the sigma notation and what it meant to expand the sum and then actually go in and calculate what the sum was going to be with those summation formulas that we had with the ends, and we did the substitution for the I-squareds and all of that. Today we're going to see a little bit more about how that's going to play into actually finding something relevant to a problem. So we are looking at finding the area. So this first example here says to approximate the area of the region between the graph of f of x equals negative x squared plus 5 and the x-axis between 0 and 2. So here is that curve. Here is my x-axis. I want to know what it is just from 0 to 2. So I'm looking just from x equals 0 here to x equals 2 here. And the way that we are going to approximate what that area underneath the curve is going to end up being is we're going to do it by putting a bunch of rectangles underneath and finding the area of each of those individual rectangles and adding them up. So first thing here, it tells us to draw 5 rectangles whose endpoints touch the graph. So first off here, we got to divide this evenly into 5 different pieces. So if my distance here is 2 and I'm dividing it into 5, each one would be 2/5 width. Now in order to put that on a graph here, the easiest way to do it is if we take this one and we cut it in half, and then in each of these halves we do the best we can to draw in 4 tick marks. Then 2/5 would be 4 of these ticks, because that would be 4/10, which reduces to 2/5. So I'm going to do the same thing between 1 and 2. I'm going to divide it into tenths so that I can count out 4/10, which will be the same as 2/5. So my first rectangle here, I'm going to go out to 2/5 or 4 tick marks out, draw straight up until it hits the curve, and then close off the rectangle here. Then do it again, 4 more tick marks over to make your second rectangle, straight up to the curve, and then over to create your rectangle. 4 more tick marks or another 2/5, straight up to touch it, and then over. Another 2/5, straight up and over. And this last one, I already have a line drawn here at 2, so I'm just going to go ahead and draw it over. So I've got 5 different rectangles here, and it says that we're going to estimate the area of each one of these rectangles and add them together. All right, so this first rectangle here, to find the area of a rectangle, it's length times width. Well, I already know that my width is going to be this 2/5, but my length is whatever my height of this rectangle is going to be, and the way that we would find it is we would have to figure out what's the y coordinate on the graph at that point. Well, if I have an x here at 2/5, and I want to know what is the y value that goes with it, I would just have to plug it into the function. So I would actually be plugging in 2/5 into this function here. So it's going to be the function evaluated at 2/5, and then times the width of the function, which is 2/5. The next rectangle, if I go another 2/5 over, this is going to be at 4/5. So I need to find the height of that rectangle by evaluating the function at 4/5, and then times the width, which is another 2/5. Because remember, each one of these rectangles is going to have a width of 2/5. The next one, if I add another 2/5, that's going to put us at 6/5. So to find the height of the rectangle, I need to evaluate the function at 6/5 times the width, which is 2/5 again. The next rectangle over, I'm going to be at 8/5. So I need to find the height by evaluating the function at 8/5, and then times the width, which is 2/5. And then the last rectangle here, to find the height, I need to plug in that 2. So I need to find f of 2 times the width, which again is 2/5. Now, you get out your calculator, do all your number crunching, but I've already number crunched these and rounded them to 3 different decimals. So if you evaluate the function and then multiply by 2/5, it ends up being a 1.936. If we evaluate it at 4/5 and then multiply by 2/5, we get 1.744. If we evaluate it 6/5 times 2/5, we get 1.424. Evaluate it 8/5 times 2/5 is 0.976. And then the last one here, evaluate at 2 times 2/5 is going to give us a 0.4. Now, in order to find what the area of all of those rectangles together would be, we just have to add all of those decimals, and it comes out to about 6.48. So that would be a guesstimation, approximation of what the area underneath that curve would be. Now, next part here is it says that was pretty tedious. And the thing is, if we were going to go and do this every single time, that would take a long time to do. So what we can do instead is we can utilize the formulas for summation that we had last time, because all we're doing is we're adding a bunch of stuff up. So we've got a formula here that says, what if we did it this way instead with the summation? And looking at the summation, this 2/5 is my width. That was the same on every single rectangle that we had. We always multiplied by 2/5. So that's what that represents. This f of 2i over 5, if you look here, in each of these, I was plugging into my f of x function, which is why it's f of here. And I started at 2/5, and then that value increased by 2/5 each time that I did it. So if I were to do my summation here and start with a 1, I would be plugging in a 2/5. Then if I plug in a 2, I would be adding then that second 2/5 or moving to this second rectangle. If I plug in an I equals 3, I'm moving to the third rectangle, all the way over to the end at 5 for those 5 different rectangles. So this part here, that's going to be our height. And now what we can do is we can go through and use the formulas that we had yesterday to calculate and figure out what the area is going to end up being when we add all those rectangles up without actually having to do the tedious work of adding all those rectangles up. So first thing we're going to do here, just like we had yesterday, this 2/5 is a constant and it can come out in front of my summation. So I'm going to have 2/5 times summation of I equals 1 to 5 of f of 2i over 5. Then if I go and evaluate my function, if you look back up here, it was a negative x squared plus 5. So I'm plugging that 2i over 5 into the x, which is going to give me a 2/5 times summation from I equals 1 to 5 of a negative, and then I plug in the 2i over 5 quantity squared, and then plus 5. And because I'm summing all of this, I'm going to go ahead and put brackets around this so I know that it's not summing here and then adding the 5 later. Then what I'm going to go ahead and do is I'm going to go ahead and simplify here and square this term so that it becomes 2/5 times the summation from I equals 1 to 5. That negative is going to stay a negative. A 2i over 5 squared. The 2 squared is a 4. Then we have the I squared, and 5 squared is 25. And then we have the plus 5. So now this is going to be what I'm finding the sum of. And now that I have this I squared, we start looking like the formulas that we had last class period, and we're going to be able to make substitutions with our n's that we're just going to be able to plug into. Now, before we do that, I'm going to do a little bit more simplifying so that we can pull things apart and separate so they're a little bit easier to work with our numbers. So I still have the 2/5 in front. I'm going to turn this into the summation from I equals 1 to 5. And here, instead of it being an I squared on top like this, let's think of it as a negative 4 over 25 times an I squared. Because then what would happen is this negative 4 over 25 can actually pull out in front and multiply by that formula that we had for I squared. And then my plus 5, which I know since that's a constant, I'm going to use that constant rule that we had. So I'm going to have a 2/5 out in front of everything. So here comes my big brackets to show that this 2/5 is times this entire summation. Here I'm going to have the negative 4 over 25. And now we do our substitution from yesterday with what I squared breaks down into. So here were our notes from yesterday in our formulas. I squared is an n times an n plus 1 times a 2n plus 1 all over 6. So I'm going to replace I squared with this. So this is going to be times an n plus 1, 2n plus 1, all over 6. And then here this 5 follows that constant rule, which just says you take 5 times n. And now for this one, since we're just trying to jump ahead to the number, we could go ahead and simplify in here. And we actually have examples later on today where we are going to go ahead and do all of that simplifying. But as for right now, let's just go ahead and plug in that 5 into all of these n's so that we can simplify and get a solution. So this is going to be 2/5 times a negative 4 over 25 times n is 5, because that was my upper limit. So this is going to be a 5. 5 plus 1 would make a 6. Twice 5 plus 1 would be an 11, all over 6, plus 5 times n, and again, our n is our upper limit of 5, so 5 times 5. And now if we take and plug all of this into the calculator, since you guys are able to do stacked fractions on your calculator, we should be able just to plug this in exactly like it looks, and it will end up spitting out a fraction for us for our answer. So 2/5, negative 4 over 25 times 5 times 6 times 11 over 6 plus 5 times 5. And it gives us 162 over 25. And if we take 162 and divide it by 25, we end up with that same decimal we had when we did it all by hand of 6.48. So that's the same decimal we had here when we did everything by hand. So even though there's all this ugly work with it, and to show someone this work that's outside of calculus and what we're learning to do might think that it looks horribly just awful, it's actually going to be easier to do it this way than it is to do it longhand the way that we did before, especially when we start to increase our number of rectangles. All right, so go ahead and flip over to the other side. We're looking at the exact same problem, except for this time what we're doing is instead of drawing our rectangles the way that we did before, with our right ends touching, now we want to draw 5 rectangles whose left endpoints are touching the graph. So to start off with, we're still doing 5 rectangles. So you still want to divide these up into 10 tick marks like we did before so that we can go 4/10 or 2/5. So go ahead and divide the 1 in half, and then best you can, 4 tick marks here, 6, 7, 8, 9. The 1 is a 10, and then put in some tick marks between 1 and 2 to divide that into tenths. And now when we go to draw our rectangles, we are going to take, and instead of going over 4 and going up to the line or up to the curve and then drawing across, we're going to start at 0 and go up until we hit the curve. Then we're going to go across and meet our 2/5 here. So rectangle comes straight across. So you can see it's sticking out a little above. So here again, if I go ahead and come in here, 2 more fifths, which is 4 more tick marks. This time I'm not stopping whenever I hit it here because it's the left side that's going to create the top of my rectangle. So it's actually going to be a rectangle sticking out on top a little here again. If I go 4 more ticks or 2/5 over again, and again it's the left side that creates the top, so it's sticking out above my curve. 4 more tick marks or 2/5 again on the left side again, so it's sticking out. And then the last one at 2, here we come across where it hit on the left side to create our rectangle. So, and let me flip back real quick. On the one that we had before, all of our rectangles were below the curve, so this 6.48 is actually an underguess. What we're going to end up with this is an overguesstimate because we're going to end up having this extra space outside of the curve. But we're still going to go ahead and go through just like we did before here. So on this one though, whenever we go and we start evaluating to find our height, we're not going to be plugging in 2/5 this time because we want to start with the height here when we plug in a 0. So our first one's going to be the function evaluated at 0 times our width, but the width is still going to be 2/5. We haven't changed that with the problem. So times the 2/5. Now this next one's height is what we got when we plugged in that first 2/5. So f of 2/5 times the width of 2/5. The third rectangle, we're getting the height from whenever we plugged in this 4/5. So f of 4/5 times the width of 2/5. The next one is whenever we plugged in this value here of 6/5. So f of 6/5 times width, which again is 2/5. And then the last one here, the height of this fifth rectangle is when we plugged in 8/5. So f of 8/5 times the width of 2/5. And now on this one, these last 4 are going to be the same as what was on the other side, because we already figured that when we evaluated at 2/5 and multiplied by 2/5, we got a 1.936. This one was 1.744. The fourth rectangle is 1.424. The last one is 0.976. And the one that's new now is this first one. And if we evaluate and plug in a 0 and then multiply by 2/5, with this one we're going to end up with 2. So now if we go through and add all of these rectangled areas together, we're going to come up with roughly 8.08. which is higher than the 6.48 we got on the other, which we expected because we've got extra space on the outsides of this curve, creating extra area that we actually don't need. Now, for the summation formula, this one's going to look a little different than the last one that we had, simply because whenever we're doing this, we don't want to go ahead and plug in 2/5 into the function over and over again, because the first one that I want to plug in is actually the one before 2/5. So I want to plug in when it's a 0. But our summation formulas that we've got only work when we start at 1. So the way that we get this thing to go backwards so that we are not starting at 1 but starting at 0 is instead of multiplying the 2/5 times the I, which is what we had before, it was 2I over 5, we're going to multiply it by an I minus 1 so that when we plug in a 1, it turns into a 0, which makes it go back to that tick or that value before the 2/5. So give ourselves a note here. This I minus 1 moves it back to 0. It moves back to 0. And then this here, when we evaluate it, that's giving us our height. And this again is going to be our width of each of those 5 rectangles. Now on this one, this next step here, all that's been done is this I minus 1 has been taken up to the top of this fraction and the 2 distributed. So the 2 times the I is where the 2I came from, and then 2 times the negative 1 is the minus 2, and then all of it over 5. So now with this one, this is what we're going to be plugging into my function. This is going to be then that constant that we're going to be able to pull out when we start doing all of our summation formula substitutions. All right, so the way this thing is going to look then is it's going to say equals 2/5, the constant we pull out, times the summation from I equals 1 to 5 of a negative, and then here's where we're plugging this value into my x to get squared. So 2I minus 2 over 5, quantity squared, and then we have that plus 5 in the original f of x formula. So now I need to square this. The thing here is, don't forget, whenever you square a binomial, we would actually have to write this guy out twice and do all of my distributing. So this is going to be 2/5 times the summation from I equals 1 to 5. I'm going to not only distribute here, but I'm also going to go ahead and distribute the negative. And actually, let me in a different color here so that it's not too much at once and confusing for you. If I were to distribute here, I would have a 2I times a 2I, which would make a 4I squared. For my middle terms, I'd have a 2I times a negative 2, and then I'd have another 2I times a negative 2. So I'd have a negative 4I and another negative 4I to make a negative 8I. And then I would have a negative 2 times a negative 2, which makes a positive 4. And now it's that I'm going to distribute my negative sign through. So that's going to be a negative 4I squared. That's going to make it a positive 8I, and then a minus 4, all over 5 squared, which is 25, and then this plus 5. All of that is inside my summation. And now what I'm going to do is I'm going to take and break all the little pieces apart so that I have fractions pulled separately away from my eyes so it's easier to do our substitutions. So I still have that 2/5. I still have the summation from I equals 1 to 5. Here, each one of these terms will divide by 25. This first one here, I'm going to put the negative 4 over the 25 and then put the I squared. So negative 4 over 25 I squared. Then this 8 over 25 and then the I. So plus 8 over 25 and then the I. And then I'm going to have a negative 4 over 25 and then the plus 5. And these I'm actually going to be able to combine into a single constant. So all of this is still inside that summation. Now I'm going to be able to go through and start doing my substitution for the I squared, for the I, and then with the constant that I get when I combine this negative 4/25 plus 5. The 2/5 is still out in front of everything. And it's 2/5 times everything inside. So first I've got the negative 4/25, and now I'm going to replace what the I squared is. And from here, I squared is going to be this n times n plus 1 times 2n plus 1 all over 6. So if we flip back and make that substitution, it was an n plus 1, a 2n plus 1 all over 6. Then I have this plus 28/5. I'm 8/25. I said that wrong, sorry. 8/25 times I, and if we go back to the formulas, I is n times n plus 1 over 2. And now this last part here, if we go to the calculator and let it do the work, a negative 4/25 plus 5 is going to give us 121 over 25. The rule with the constant is it just gets an n. So it's going to be plus 121 over 25 times n. And now here again, as we get further on and we start looking at the last part of this lesson, we're going to go through and we're actually going to leave all of the n's in it. But at this point right now, since we're just hunting for a number, let's go ahead and actually plug in my n equals 5 into all of these n's. We'll run it to the calculator and see what it comes up with. So this is going to equal 2/5. This is a negative 4 over 25. And now my n is 5 because that was my upper limit. So if I go ahead and plug in, that's a 5. One more makes a 6. Twice 5 plus 1 is 11 over 6 plus 8 over 25 here times my n, which is 5. One more makes 6 over 2. And then this last one is going to be plus 121 over 25 times n, which is 5. And now if we take and plug all this into the calculator is going to spit out 202 over 25, which is the same thing as 8.08. So the exact same thing we got up here by evaluating. And now the thing is, I realized in class while we're doing it, it seems like that one up top was a whole lot faster because we didn't spend near as much time on it. But just keep in mind, the reason we didn't spend near as much time on it is because I was giving you these answers. You would have had to have been plugging this into your calculator, figuring out what the function is evaluated at each of these values, and then multiplying by 2/5, writing that number down, adding everything up. You'd have done that 5 times. And then the question down here is what would happen if instead of doing it with 5 rectangles, we did it with 25 rectangles? So now you would be punching numbers into your calculator 25 different times. Now that we've got these formulas from our summations, though, we can just use those to help us out so that then all we have to do is plug in those new values for n for it to spit out our answer. So we'll go ahead, last thing for this lesson before we're going to have to call it quits and hold off until tomorrow before we start looking at the last page of part 2. But we are going to separate then into 2 separate right endpoints and left endpoints, just like we did using our formulas from the front side and the back side, but with 25 rectangles instead of 5. So when we started, we wanted the right endpoints. So these were our right endpoints, and the formula we had was this one here before we plugged in a 5. So, and I actually have it on another paper in front of me so that we don't have to flip back and forth to copy it down. But go ahead and label here. This first one is going to be our right endpoint. And the formula that we had was 2/5 times a negative 4/25 times n times quantity n plus 1 times quantity 2n plus 1 all over 6 plus 5n. And now for us, this go around, our n is going to be 25. So if we plug in 25 then for all of our n's, we're going to get 2/5 times negative 4/25 times, that's going to be a 25. One more is going to make 26. Double 25 plus 1 is going to make a 51 all over 6. And then plus 5 times 25. And if we number crunch all of that into the calculator, it's going to come out to 4,482 over 625, which is roughly 7.1712. And now we'll take a look if we did it with our left endpoints, which is what we just did up here. So I'll pull that down a little so we can still see it. Go ahead and label here. We've got our left endpoints. Our formula is this one here before we started plugging everything in. So it's 2/5 negative 4 over 25 times n plus 1 times 2n plus 1 all over 6 plus 8 over 25 times n times n plus 1 all over 2 plus 121 over 25 times n. And now if we go in, and in all of these n's, we plug in 25 for the 25 rectangles, we're going to get 2/5 times negative 4 over 25. That's going to be a 25. One more makes 26. Double 25 plus 1 is 51. All over 6 plus 8 over 25 times, that would be a 25, times one more is 26, all over 2, plus 121 over 25 times 25. And if you number crunch all that into the calculator, you get 4,682 over 625, which comes out to about 7.4912. And now if you look, when we did it with just 5 rectangles, we knew that the area was going to be somewhere between 6.48 and 8.08. Now that we've added more rectangles, now we know that the actual area is somewhere between 7.17 and 7.49. So you can see as we start adding more rectangles, our actual area is getting closer and closer to what it really should be. All right, so at this point, we're going to stop for the day. I am going to go ahead and stop this video and create a whole new one for the last part of the lesson. On here, you do have some homework assignments, or some numbers assigned on page 9. In the book, it's page 299. This first 25, 27, 29 says to find the area, or to do it by finding the area of each rectangle. that's what we just did. So it's these three problems that you're able to do tonight. When we pick up next class period, we're going to be looking at this thing called upper and lower sums, and that's going to be when you're able to do the last two. So be sure you get those first three practice, and we'll pick up where we left off next class.